should be able to finish this up. That means that for a week from Monday, you will need to make sure you go over to Bare Necessities to get your book for second semester, okay? But so Friday next week, we'll do the test on this stats unit, and then we'll go from there. Sound like a plan? All right, where do I want to teach at today? Somewhere fun, inviting. How about this front seat? Sturpy always go there. Here.
Thank you.
All right. So let's run through any questions you had on 205, 206, see if I could answer those for you. Let's check better. What could I help you with on 205, 206? It was just the odds, right?
Yep.
Cool.
Number 9.
Number 9. All right. You have, for number 9, you have these tiles. T, I, G, E, R. Okay? Just arbitrary looking tiles. Let's say we're mixing them all up in a baggie or a container that we can't see inside. We want to know, we want the probability that we pull the 6 tiles in. I guess it's only 5 tiles, isn't it? So it should be the probability that I pull 5 tiles in order. Okay? All right, so we're going to try and pull a T. The probability I pull a T out is 1 in 5 is the T. So assuming we pulled the T, that leaves us a 1 in 4 chance of pulling the I. And then pulling the G, there's only 3 tiles left, 1 in 3. And then there's only 2 tiles left, bless you. It's 1 in 2. And then you have 1 out of 1, which the last one's kind of funny because, of course, you multiply by 1. So you multiply top, 1 times itself, 5 times. Then 5 times 4 is 20. 60, 125 by 1 in 120 chance probability of me drawing those tiles out in that exact order. So I have 119 out of 120 chance that I pull them out in any other order. Okay? 11. Yeah, ooh, thanks for asking about number 11. So number 11, this kind of gets goofy. Okay, so we have an A tile, an R, a D, a V, A, R, K. All right, so what we have to think about is these tiles are all the exact same size. And I have some duplicates, so I can't tell the difference between the first and the last A. And then I have the D, and then the V, and then the K. All right, so that's 8 tiles. 1, 2, 3, 4, 5, 6, 7, 8. I have 8 tiles total. So the chance that I pull, I put all those tiles into a baggie that I can't see in. I shake it up and I pull them out. The probability that I pull an A out first is, well, I have 3 A's. So I have a 3 in 8 chance of pulling that out. Okay? And then to pull the second A out, there's 2 A's left in there, so that's 2 out of 7. Okay? Then if I want to pull the A out, or the R out, excuse me, I have 2 R's, so there's 6 tiles left in there, which is this. And then if I want to pull, so I have the R, The D, there's only one, but there's only 5 tiles left. The V, there's only one. There's only 4 tiles left. The A, there's only one A left in there, and there's 3 tiles. The R, there's only one of those left in there. And then the K, there's 1 out of 1. Now, in stats, one of the things that'll help you out, especially if you have these kind of combinations, yes, plugging this into a calculator will find you it. Unfortunately, sometimes numbers get too large for the calculator and it starts putting in scientific notation, and if it gets larger than that, then it gets a little goofy. So things I would do in this situation first, if you had it all listed out, and this will be easier for you, is realize that 2 goes into that 8 4 times. Okay? This 3 goes into that 6 twice. This 2 cancels with this 2. And there's nothing else. I have only 1s left on top. So I have a 1 out of, let's see, 4 times 7. Oops, yellow wouldn't be best. That's 28, 20, and 60, and 120. So I have 120 times 28. So 0, 16, 1, 860, and then 240. So 2400. So 0, 6, 12. So I have a 1 out of 3,260 chance that I pulled out and spelled aardvark. And we have to make sure that we are understanding that the A's are the exact same tile. There's no discrepancy. We don't have like the first A, the second A, and the third A. It's just A. Okay? That's how you go about that. Yeah.
I got it right until the 1/5, and I didn't get any of the numbers after.
You did what? I'm sorry.
How did you get the numbers after?
Okay. So this was pick 1, 3 out of 8. Because there's 3 A's. Okay. The second A, because I've already pulled an A out, I have only 2 left out of 7. And then I get to the R. There happens to be 2 R's, and there's 6 tiles left. And then I get to the D. There's only 1 D in the baggie, but there's only 5 tiles left. And then I get to the V, and there's only 1 V in the baggie, and there would only have been 4 tiles left. And then I get to the A. Even though there was 3 A's originally, there's only 1 left in the bag if I have already drawn 2 of them. So then there's only 3 tiles, 1 on 3. The R, there's only 1 R that would have been in there. And there's only 2 tiles left. And then the 1 out of 1 is kind of goofy because it's not going to change the fraction. Does that make sense? So it's a matter of, you are assuming you pulled the letters in that order. You're not necessarily running through the iteration saying, but I didn't get an A on my first guess. I understand that, but if you did, that's how it would work. Were there any other questions I could help you with on 205, 206? Yeah. 15. Let's see, number 15. Okay. So, in the Colorado Lottery, a machine dispenses a ping pong with a number on each ping pong. The numbers go from 1 to 45. Okay? Numbers 1 through 45. So, count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, all the way to 45. I have 45 balls that are in this big old bin that is mixing them around. Okay? Now, order is not important on this. And you get to select 6 numbers. So I want to know the chance of these numbers in whatever order is possible coming up. And I don't put the ball back into it so I can't get duplicate numbers. Okay? So basically, this would be a 1 in... Actually, let's not do this. Because order wasn't important. I can pick... My first guess is all 6 numbers. Because there's 6 numbers out of 45. And then once one of the numbers is drawn, then I'm trying to get to 5 more numbers. So that'd be 5 out of 44. And then there's only 43 balls left in there. And so I'm hoping to get there's a chance of 4 and 43 of that happening. And then a 3 out of 42. And then a 2 out of 41. and then a 1 out of 40. And again, this is one of those where you might want to see about reducing it to help you out a little bit, or at least help your calculator. This 3 goes into here 3 times. This 2 goes into there 20 times. I'm just reducing wherever I can. Let's see. This 6 goes into 42 7 times. This 4 goes into 44 11 times. So I have a 1 on top. And then, let's see. Somebody have a calculator? I can do some of it. So 3. Does anyone have a calculator right there? You ready? 3 times 11 times 43 times 7 times 41 times 20. So I'm multiplying these together. Holy crow. 8,145,060. I think that could be very, very close. Yeah. So you have a 1 in 8,145,060 chance of you drawing 6 balls that you've selected the number in whatever order to come out. Yikes. So, Stirp, you're saying there's a chance I could win? Yeah, but that means that you have 814,559 combinations other than you selecting those 6 balls. Yikes. Anything else? Good? Happy? Content? All right. Let's go to 4-4, which is page 90-ish, 92, page 92. Okay, and I think you're going to like contingency tables because it becomes a very visual way to represent statistics. All right, so I'm on page 92, and it looks like they have Atlantic, Pacific, and the Indian Oceans. And we have different category 1, 2, 3, 4, 5, and then we have the total hurricanes. And then we have the total down this way. All right. The nice thing when you do these, you fill in the data, you have 20, 16, 10, 5, 2. And if I add all those up, I would get a total of 53. And then if I come across with Pacific, I have 16, 8, 6, 5, 4, and there's 39 that happen that way. And then if I go with the Indian Ocean, I get 10, 4, 2, 1, and 1, which is 18. And then if I total my columns, so if I total straight down, that gives me 46. If I total straight down this way, that gives me 38. If I total down this way, Bryson, this gives me 18. If I total down this way, it gives me 11. And if I total here, it gives me 7. And then the total going this way and the total going this way, they have to match, means there was 110 hurricanes that did take place in one of those 3 oceans, ranging from category 1 to category 5. Okay, category 5 being the worst. So the 2 variables in the problem summarized as ocean and intensity of the hurricane. The data in the table are raw counts, not percentages or means or anything else. Tables contain data that are not counts, certainly exist, but they are not contingency tables, and they will not be discussed here. Okay, so if we wanted to know, for example 1, they're saying the probability of getting a category 1 hurricane. Okay, how many category 1 hurricanes were there total? Yes, I haven't know the answers there, but I just want you to see where it came from. Category 1 is this column. There's 46. So I have a 46 out of the total number of hurricanes out of 110. Yes, you can reduce it if you like, but there's no reason to. Okay? And then if I move on, if I wanted to get example 2, probability of selecting a 3 or higher hurricane. Okay? So that means I want to count this one, and this one. So 18 and 11 is 29. 29 and 7 is 36. And I still have the 110. And again, I could reduce that fraction if I wanted to, but the contingency table is a really valuable tool when you're working these types of things out because the data is in front of you. Probability of an Atlantic hurricane. Okay, and they don't care. So the Atlantic hurricane, there happens to be 53 of them out of 110. And then for number, if we want to do the probability of selecting Atlantic or Pacific. So Atlantic is 53. Pacific is 39, and there's 110 total. So if I add the 53 and 39, I get 92. I have a 92 out of 110 probability of that taking place. Okay, so that just dealt with combining these numbers together to get there out of the total. And then probability of selecting Atlantic category 1. So Atlantic category 1 is a 20 out of 110 probability. And sometimes with these, it's nicer if you convert it to a decimal because that's easier to figure out the percent chance. And then example 6, probability of selecting Pacific and less than category 3. So that means it's category 2 or 1. So Pacific less than category 3 is 16 and 8. 16 and 8 add together to give me the 24. And I have a 110 probability out of 110 total. And then example 7, the probability of selecting a category 1 or a Pacific. All right, this is one that you want to be cautious that you don't double count. So I want to know the probability of counting a category 1. So it's category 1 is these, which basically a category 1 is 46. Or a Pacific. So if I do Pacific, it's here. All right, so for my friends, I'm going to highlight something here. Don't double count that 16. Okay? The Pacific has a category 1, but I already counted that 16 as part of the category 1 thing. I don't want to double count it. So then I'm going to add 8 and 16, or 8 and 6 is 14, 19, 23. So I have 46 plus 23 out of 110. If I add those together, I wind up getting 69 out of 110 probability that those would take place. So the contingency table is a really nice visual way to represent this. Okay? So in each of these cases, we had the 110 as all of my denominators because we were looking at the totals. Okay? Do you remember yesterday when I talked about there was something that said, what's the probability of B happening such that A happens? That's where this is going to start kicking in because we're going to start doing either dealing with the row totals or the column totals. So let me reduplicate this grid. So I have Atlantic, Pacific, Indian. I have 1, 2, 3, 4, 5. And so I have 20, 16, 10 with a 46 total. I have 1684 with a 38 total. I have a 1062 with an 18. I have a 551 with a 7. And I have a 241 with 7. The total's over here, so categories that. And then in the totals, I have 53 over here, 39, 18. The total of everything is 110. Yeah, that works. Okay, so now we're going to talk about conditional probability. It's a little different. Conditional probability always asks for the probability of an event given a condition had taken place. So example 8. I want a probability of a Pacific hurricane will be a category 5. Okay? So what this one is meaning is we are worried about this region only in my contingency table. Let's make that a little nicer. I'm worried about this is dealing solely with this one. Okay? I'm not worried about the rest. So I want a Pacific hurricane that is a category 5. Okay, how many category 5s fell in the Pacific? Anybody? 4? How many hurricanes happened just in the Pacific? Yeah. Okay, so this is what's the probability I pick a category 5 such that we're dealing only the Pacific Ocean. I eliminate the rest of the data. Okay. Previous problem is often written as conditional probability notation. So this is probability that a category 5, and they use this right here. This means such that we are in the Pacific. Okay. So you look at your data going, all right, let's worry about just the Pacific Ocean. Worry about California and Hawaii. They had 39 hurricanes. What's the probability of those hurricanes that came through was category 5? I have a 4 out of 39 chance that took place. Okay. Example 9. Example 9 says I want the probability that I'm Atlantic such that category 1. Okay. So a category 1, let's see, I'm going to go this way. Highlight. So notice they're going Atlantic Ocean here. So that's all we're worried about on this one. Okay, so I'm going to say in the Atlantic Ocean, I have a total of 53. How many category 1s were there? There was 20. Okay, so again, you're not using the entire grid to do this. Then let's go to example 10. So I want to know a category 3 such that we're dealing with the Atlantic or Pacific. Okay. Okay, so I want to go, bless you. I want to go here, and I want to go here, Atlantic and Pacific. So we have to think about what's the total there? Well, I have 53 plus 39, which gives me 92. That's my denominator. And then a category 3 in the Atlantic and the Pacific. There's 10 in the Atlantic, 6 in the Pacific. So I have a 16 out of 92 probability that I pick a category 3 such that I'm only selecting the Atlantic or the Pacific. And then example 11. I want the probability that it's category 3. Wait. Atlantic category 1. Atlantic category. Oh, shoot, that's 9, 10, 11. Sorry about that. And then 12. Example 12 is I want Indian Ocean such that category 4 or 5 takes place. All right, so Indian Ocean, highlight. Don't know what color that is, but we're going this one. Okay. So, Indian Ocean, there's a total of 18 hurricanes that took place there. Category 4 or 5, you're dealing with just those two, so 1 plus 1 is 2. So 2 and 18. Okay? So there's two variables in the problem. There's intensity of the hurricane and the ocean it occupies. The variable intensity of the hurricane is measured with 5 levels, category 1 through category 5. Ocean is measured at 3 levels, being Atlantic, Pacific, and Indian. So some observations. Outcomes in category 1 and category 2 are mutually exclusive because you can't have a category 1 and a category 2 in the same storm. Yes, a storm could get classified higher, but it doesn't say, oh, it's a category 1, now it's category 5. If it goes up to the max, it just becomes category 5. The outcomes of Atlantic and category 5 are not mutually exclusive because you can have a category 5 in the Atlantic. The outcomes Atlantic and Pacific are not complementary because the outcomes are not other outcomes are possible, which is the Indian Ocean. Okay? Complementary meaning probability one versus the other. Being I have a third location, that's not going to allow it to be complementary. The issue whether hurricane level is independent of the ocean occupies a more important one, a bit more complicated. Independence can theoretically be tested with a couple of calculations. So category 5 is about 6.4%. And then category 5 in the Atlantic is about 3.8%. Okay, since the probability of the hurricane of category 5 seems to be lower for the Atlantic hurricanes, this adds evidence that the idea that category 5 hurricanes are less likely for the Atlantic hurricanes, and therefore that the intensity of the hurricane depends on the ocean where it occurred. Okay, but be cautious about this. This is only talking about like one season of hurricanes. Okay, you have lots and lots of other data that came from other things. Later, we're going to learn something about the chi-squared test, and this is another thing that will test whether our data has validity to it or not. Okay, that's all I have. I'm sorry, I wish I had more. I know you are wishing I had more, but we are going to do something. 4-4. All right. Let's have us do 4-4, page 207, 1 through 13 only. So it's just the first page. It just deals with one contingency table. Okay? And that's all I have for you. Good done.